It should work. All right. Okay, find the exact value of cos 75. Well, we did those ones last week. So if you remember cos 75, we need to break it up into like cos 45 and 30, and then expand. Sine 105, we broke that up into sine 60 and 45. And again, expand. Tan 15, you could do tan 45, take away tan 30, or even tan 60, take away 45, and again, expand. Okay, so we've got these questions now. If A and B are acute and cos A equals 3 over 5 and tan B equals 2 root 6 over 5, then simplify sine A plus B. Well, we know that sine A plus B is sine A cos B plus cos A sine B. Now it's great, I've got cos A, there it is, but I don't have sine A, cos B, or sine B. Anybody have any clue of how I'm going to be able to find sine A, cos B, or sine B?
Tan B equals to sine B over cos B.
Fair enough. Different. Yes, that can work. Clever.
The triangle?
I think that's a bit better. Cos A, but Greg, your way, don't think it's wrong. It's a pretty good way to do it as well. But right now, let's do it that way. So cos A. So we're going to create a triangle. There's your A, adjacent over hypotenuse, 3, 5. This one's obviously a 4. And then we'll do the same thing for B. There's B, opposite over adjacent. And then let's do this 2 squared times 6 plus 25. Root answer 7. That worked out really nicely. Okay. And then, of course, sine A is opposite over hypotenuse. So that becomes 4 over 5 times cos B. Cos B is adjacent over hypotenuse. So 5 on 7 plus cos A. Cos A is again equal to adjacent over hypotenuse. Or cos A. Yeah, adjacent over hypotenuse. 3 over 5 times sine B. Sine B is equal to opposite over hypotenuse, so 2 root 6 on 7. And I think I can see the answer being coming 20 plus 6 root 6 on 35. Any questions for that one?
No.
That made sense to everybody? Great. Look, then I'll know you can do B now, because again, you're just going to expand it. You've already got your triangle. I know you can do C, because C, sine 2A is just 2 sine A, cos A, and if you haven't memorized that, but you have memorized, I don't know, your expansion of sine A plus B, you could just do that. Sine A plus A and then just expand, and then obviously you'll actually prove 2 sine A cos A. Same thing with tan 2A. Tan 2A is 2 tan A on 1 minus tan squared A. Tan A is what? Tan A is opposite over adjacent, so 2 times 4 over 3 over 1 minus 4 over 3 squared. Personally, I would just plug all of this into my calculator, right? Because I can see there's no surds or anything, so whatever the answer is in your calculator, it'll work out, right? Cool. Let's look at question 3. Simplify the following. Cos minus sine. That looks pretty interesting. Anyone feel like they know the answer to this? Cos something.
Cos 4A minus A? Oh, cos 4A plus A, sorry.
Cos is going to be the opposite one, if you remember that. So if this is minus for cos, this is going to be a plus. Can everybody see how we got that? Cos 4A plus A. If I expand this, it becomes cos 4A cos A. There it is, cos 4A cos A minus sine 4A sine A. So the answer to that becomes cos 5A. Same thing with the next one, cos, sine. So the answer obviously is going to be cos 2a minus b, since there's a plus. And cosine, which means it's sine 2a plus b minus, with sign that's the sign, the negative sign doesn't change. So 2a plus b minus and then 2a. Any questions there?
Wait, can you do the last one again?
Yes, of course. So, just quickly tell me, can you see that it becomes a sine firstly compared to it's a cos? Can you realize this? Yeah, great.
Yeah.
What's your first angle?
So 2a?
Plus b. Isn't this your whole angle?
Yeah, plus b.
And then what's your second angle?
So cos 2a plus.
No, hold on. So, what's your for a? What's your first angle?
Mm.
Your first angle is 4a. 4a.
Yeah.
What's your second angle?
Or a?
A and A. Just A. So realize, hold on. What you got to realize with your formula, you're going to have the first angle plus a second angle.
Mm.
And that becomes your first angle, second angle, second angle. Do you get that?
Yeah.
So if I go back to here, question the first one, 4a, 4a, well then that becomes just 4a. And then I can see an A and an A, and that would be an A.
Okay.
And then I know that cos, because it's a negative, becomes a positive. If it was a positive, it becomes a negative, and we did that.
Yeah.
Same thing with the second one. The first
2A.
one's 2a, second one's B and B. So my first angle is 2a, my second angle is B.
Plus b is 1, and then the other one's just 2a.
Yeah, that's the idea. So the first one is 2a plus B, the other one's 2a. And then with sine, if it's a negative, it still stays as a negative.
Okay.
And then 2a take away, yeah.
Makes sense. Okay.
Good job, perfect. Everybody else, all good with that?
Yes.
Yep.
All right, interesting. Let's do question 4. I don't think we did C. Did we do C last week? Doesn't ring a bell. I don't know. Did we do C? I feel like we did. But why not? Let's just do it. I can fit it in here. All right. Who wants to try the expansion of the top with me together? So sine. Expand this. Come on, someone just step forward and do it with me.
Is it sine alpha
Yep,
plus cos beta?
not plus,
no.
so sine alpha.
Sine alpha
Cos.
plus beta. Minus or plus?
Plus. Why? Sine doesn't change.
Yeah. Yeah.
And?
Plus cos alpha sine beta.
Beautiful. Plus the next bit.
Sine alpha cos beta minus cos alpha sine beta.
And then what can you see from these two? What will happen?
The first ones will cancel. Well, no, the second one, cos alpha sine beta, will cancel.
Done. And what are you left with in the top? Just sine alpha cos beta plus sine alpha cos beta, which becomes 2 sine alpha cos beta. You agree with that?
Yeah.
Done. That's numerator over denominator now. Denominator is going to become cos alpha cos beta minus changes sine alpha sine beta plus, do it again, cos alpha cos beta says minus, I've got to plus it. Sine alpha, sine beta. Again, these two cross out. I'm left with two of these, cos alpha, cos beta plus cos alpha, cos beta is 2 cos alpha, cos beta, and then of course I think we can all tell cos beta cancels out, 2 and 2 cancels out, you're left with sine over cos. Any questions for that one? Did that all make sense to you?
Yes, sir.
Beautiful. All right. Like I said, all the answers are here for you guys, so you can just go back and rewrite everything as you need to. Why did this one look so long? Ooh. Cos. Given that fit, oh, there's 2 different questions. I was like, why is it so long? All right. Prove the following. We were doing these ones last week. We did most of them. I'm happy with the proofs. I think we've got to do more solving questions. Okay. We're going to do these 3. Okay. F. Cos 2x. Actually, I'll do F up here first. Cos 2x equals cos x. All right, Stefan, let's do this one together.
Yeah, can you hear me?
Yes, I can. Cos 2x.
Cos 2x?
Yep. There's 3 formulas that you wrote, right?
Yeah.
Now, you're not going to choose the one that has a sign. The reason why you don't choose the one that has a sign is because you can see here, it says cos.
Cos.
So you want to probably choose cos 2x as the cos squared option. So tell me, cos 2x becomes?
Cos squared theta minus sine theta. Sine squared theta.
Yeah, but you don't want to choose that one.
Oh, then you want to choose 2 cos squared theta minus 1.
That's the one.
Yeah. I had a mind blank, don't worry.
All good. And then, what are you going to do now? Do you want this cos x on this side? Remember, you're trying to solve.
Yeah.
So, do you ever have x's on 2 different sides?
Nah, you want it on just one side. Cos x minus 1, 0.
Okay, and then what does this look like to you?
What does it look like? Well, wait, let me just find it.
It's not.
Oh, it
it's
looks
not,
like quadratic.
Yes, quadratic.
Yeah.
What were you looking for? To find that?
I was looking in my brain, don't worry.
All right, quadratic, correct. It's just a quadratic, simple. Cos x, good job. Cos x equals, I'll just do it from here now. Cos x equals minus b, so 1 plus minus square root b squared minus 4 times a times c all over 2a. Next line. Is everyone keeping up with me? Do you want to go back over any particular lines? Do we understand how we got from this one here to this one here?
Yep.
Anyone not know what we've done there?
I see.
Andy, you saying you see it, you get it?
Yes, I do see.
Yep. Anybody else that can't see this, doesn't understand what's happening or how I transform that to that? Some of the Foyner kids, you probably saw that the other day on Monday. We had to do that, cos 2x, transform that to from double angles and powers of squares. Okay, cos x equals 1 plus minus square root 1 plus 8, I think. Yeah, it looks like 1 plus 8, which is 9. 4, 1 plus 3 is 4, 4 over 4 is 1, 1 take away 3 is negative 2, so negative half. if I haven't done anything wrong. Those are your two solutions. Then we're going to write cos x equals 1 or cos x equals negative a half. Then for cos x equals 1, we just go inverse cos of 1. The first answer you get is 0. Then you do all stations to central. Where is cos positive? Here and here. So my next answer is 360 degrees. Then I do this one here. Don't forget, it's a negative. I'm not allowed to put a negative. So x with some hats becomes inverse cos of positive half. That's the way we've been doing it. That's the way you stick to it. So that becomes 60 degrees. That isn't your solution. Your solutions are here. Where is cos? Which means plus, which is 240 degrees. Therefore, our final answers are 0, 2 pi, 120 on 180, 2 pi on 3, and then 240 on 180. Should be 4 pi on 3. Yep. All right. Let you guys go through that. Let me know what line you want me to go over again. I'll scroll up for a little bit just so you can see where I started from again. Cos 2x, transform that to cos squared because the right hand side said cos. I brought everything to one side, used the quadratic formula. Then I've just got two equations, solve them. This is a negative, so I can't. I find my 60 degrees, and then where is cos negative? And then how do I convert these degrees to radians? Just divide by 180 and put a pi in there. Any questions for this? No? All right, can I move on? Everyone's ready for me to move on?
Oh, yeah.
Yeah.
Thank you. Okay. Cos 2x equals sin x. Who's gonna do that one with me? Andy, do you wanna try this one?
Yes, I guess. Alright,
Cos 2x.
alright.
Now,
So it goes,
you want to choose, hold on before you say it, you just want to choose the one that only has sine by itself. So we're not going to choose cos squared minus sine squared. And we're not going to choose 1 minus, no, we're not going to choose 2 cos squared x minus 1. There's only one more left. It starts with a 1.
one minus 2 sine squared.
Yeah, good man.
Thank you.
1 minus 2 sine squared x equals sine x. What do you do now?
Move the sine x over.
I would have personally moved these two over to keep this as a positive.
Oh yeah, that's
But
right.
it doesn't matter. And then sine x equals, well, minus b, which is what?
Minus b minus 1.
So
Or
positive 1.
Yeah.
Yep. Plus minus square root b squared
1.
minus 4 times a
Negative 2.
times c
Just 1.
all over 2a. All right. Let's plug this into
Wait, and why is it just positive 1 instead of negative 1?
for where? This one here. The
Yeah.
first one minus b, but b is negative 1. So
Oh, yeah.
negative.
Yeah.
Thank you. Square root 1 minus 4 times negative 2 times 1 is 3. So that becomes 1 plus minus 3 on negative 4. That becomes negative 1, and 1 take away 3 is negative positive half. Okay. All right, Andy, we might as well finish this off together. So we get sine x equals a half. What do you do now for that one?
Chuck that into your calculator.
How? So x equals, what are you going to chuck in?
Sine,
Sine half?
yes.
No,
No,
inverse.
inverse, yeah.
And then, what do you draw?
That ASTC,
And you ask yourself, where is sine?
A and S, positive. So that'll be 30 and 150.
Done. That's that one done. Then we've got to do negative 1. What do you put in?
Inverse sine 1.
Inverse sine,
Yeah.
positive 1.
Yeah.
It gives
That'll
you
become
90.
90.
Where is sine negative?
T and C. So it'll be 270.
180 plus and 360 minus, it's still just 270. Therefore, x just equals to pi on 6, 150 on 180, 5 pi on 6, and 270 on 180. 3 pi on 2. All good with that, Andy? Everything made sense?
Yeah. Just had a few mind blanks.
Where? Where are you having mind blanks though?
Oh, with the inverse sine.
Yeah, that's okay. Look, this is worth 4 marks in your extension 1 exam. All right, it's some serious marks. For
Alright.
something that is very, to me at least, it's very repetitive in nature. So, I mean, you've already done quadratic formula before. You would have already inversed before. All stations to central, simple 2-unit stuff. The only thing that's actually extension 1 is this line to this line. Everything else can be asked in 2-unit. So, it's pretty easy marks to get in an extension 1 exam.
Sounds good.
We're going to do h sine 2x equals 10x. Rosemary, sine 2x equals 10x. This one's going to be yours. Just let me know when are you ready for it?
Yeah.
Let's go. Sine 2x. All right, what does that become?
Sorry, my brother's so loud.
I know, it's okay. We can barely hear him, so fine. So sine 2x becomes 2 sine x.
2 sine x cos x
Yeah.
equals 10x.
And then what? No, you don't want to write just 10. There's no point. You're gonna shoot yourself in the foot. There's no point. Change 10. What do you think 10
Cos
becomes?
on x.
Say it again.
Cos on x.
No.
Sine on x.
On
Sine x on cos x.
Yes, please go over it. Sine x on cos x. All right, and then what are you going to multiply now?
Cos x.
Yeah, you're going to multiply it by this side. And then you really don't want the sine x here, so you're probably going to move this one to the
left-hand side.
Left-hand side, and then do you like cos squared here?
No.
So what are you going to do to cos squared? Cos squared x. What do you want to change cos squared x to?
One minus sine squared x.
Yeah. And then expand.
Minus 2 sine cubed x minus sine x.
And then simplify. So just hold on. Okay. Now this is definitely not a quadratic, right?
Yeah.
What are you going to do if it's not a quadratic to solve for this? Cubed and sine x. What does your head tell you to do?
Factorize.
Yep, that would be correct. -2 sine
Sine
squared.
squared x plus 1. And then sine x equals 0. And 2 sine squared x equals 1.
-1 divided by
-1.
-2 is positive half. Did you
Yeah.
see what I did there? I subtracted the 1 and I divided by -2.
Divided by 2. Yeah.
All right, finish it off. X equals. This one's a bit of a tricky one for everyone to get the full answers.
0,
The first
180,
one's 180. Now just keep in mind some
360.
360. Why is 360 a solution? Because if you add 360 degrees to 0, it's still within your domain from 0 to 360, right?
Yeah.
So you've got to include that 360 degrees in there.
Yeah.
All right, good job. And then if you remember this from last week, we said if you have a squared, you can, when you square root it, you're going to get
It's
plus minus.
negative and a positive.
Yeah, which means it's all 4 quadrants.
Yeah.
So once you work out your positive case for shift 1 on root 2, then you can just do all the other 4. Shift sign 1 on root 2 should be 45. Yeah.
Yeah, 45
And 180 minus,
on 35,
180 plus,
225,
and 360 minus.
315.
And you got 1, 2, 3, 4, 5, 6, 7 solutions that you got to write in radians now,
Yeah.
which is annoying, but you know, it is what it is. Good job. Thank you.
Thanks.
Just before you go, Rosemary, with that actually, you know where you got stuck. I don't need to tell you.
Yeah.
Please just go back over your basic formulas. Otherwise, I know
Yeah.
your math is good. So just be aware of that. 5
Yeah.
over 4, 315 over 180 is 7 pi over 4, and that should be all of our answers. 1, 2, 3, 4, 5, 6, 7. Yeah, good. All right. How'd you feel about that one?
It was good. I
Yeah?
get it. Yeah.
Everything makes sense? Oh, that's great.
Yeah.
Everybody else all good with this? Everything's making sense? This would still be worth 4 marks. It's not really a 5 marker just yet. You'll realize what a 5 marker looks like when you start doing some exam questions. Good. T formula. Did we do T formula last week? I don't think so, but just...
No, we
No.
didn't.
Yeah, I didn't think so either. All right, good. So we've got exercise 5 to do. Just want to see what's left. T formula. I think solving is now part of year 12. So I think the rest of this is part of the year 12 topic. So there's no point in me doing them just yet. I will just double check with your syllabus. So give me a second. I don't want to miss nothing. And I don't want to overteach you right now. And we can actually focus on strengthening our year 11 concepts. Year 11 extension 1 textbooks. Restricting the domain, defining inverse, graphs involving trig functions, double angle, just T formula, products to sums. Which one's that one? 805 product to sums. T formula and 2 sine A cos B is just becomes this. Okay, yeah, that's nothing. All right, yeah, so T formula not solving, right? Just proving. Suppose that find the exact value. Yeah, just proving. Prove. Use find the exact value. Yeah, no solving. So that's next year. Next year we'll have to use it. It's weird that they split it up like that. It's annoying. Would have been easier just to teach the one thing when you know it. All right, so let's do this bit and then we'll do some of your 3D trig stuff, which will be really different. All right, T formula. The best way to memorize your T formula, so the idea with this is we've done double angles, so we did, you know, sine 2 theta and cos 2 theta. These called double angles because they're obviously multiplied by 2. T formula is half angles. So you're halving the angle. We're representing tan theta on 2 as the letter T. It just simplifies it rather than trying to write fractions within fractions and stuff like that. From that, we actually can derive a particular, well, I'll tell you exactly where it comes from. I think it's pretty neat. So you guys have memorized tan 2 theta is 2 tan theta on 1 minus tan squared theta, right? If I halved each angle, which means this now becomes just theta, this becomes onto, what you actually end up getting is tan theta is 2 tan theta on 2, which is t, so 2t on tan theta on 2 squared, 1 minus t squared. From that, we're able to get this triangle, which is what you're going to just memorize. There's no point of memorizing everything. So theta, opposite, over adjacent, and then I promise you, if you do your Pythagoras' theorem properly, you will get this bit becoming 1 plus t squared. I'll leave that for you to prove for the hypotenuse. Then we end up with 3 different results. We end up with, obviously, the tan theta is 2t on 1 minus. We end up with sine theta as 2t on 1 plus. And cos theta as adjacent over hypotenuse. And this is effectively the last formula I need you to memorize. But it's easier to memorize the triangle than it is to memorize these 3 results. So just memorize this triangle, which is actually really straightforward. So 2t, 1 minus, 1 plus. Okay. Let's take that and let's see if we can show some of these questions out. Let's do the little triangle again. Theta, 2t, 1 minus t squared, 1 plus t squared. From that we can get sine, cos, and tan. Sure. Okay. Greg, let's do this one together.
Yeah.
All right, let's do it. Left-hand side. Left-hand side is equal to sine theta
Yep.
on 1 plus cos theta.
Yeah.
And, okay, wait, hold on. You guys, in your exams, because I'm sure you're going to ask that soon, I mean, how would you have known to use T formula? The question would have said, given that T equals tan theta on 2. So it'll actually guide you like that. They don't just expect you to just go, give you a question and just say, show sine theta on 1 plus cos theta equals T. Because you can't actually show something like that without knowing that T is tan theta on 2.
Yeah.
We'll continue. What is sine theta equal to, Greg?
2t on 1t, or 2t on 1 plus 2t squared. T squared, sorry.
Just 1 plus t squared. Yep.
Yeah.
Because this is a fraction, I'm not going to write it over another fraction, so I usually just do it like this. Divide 1 plus, and then what's cos theta?
Cos theta is 1 minus t squared over 1 plus t squared.
Okay. There's nothing you can do to this bit, so you will just rewrite it. What are you going to do here?
You would just add, so you would add a 1 plus t squared to the thing.
Common denominator. Yes?
Then you would end up with 2 on 1 plus t squared divided by 2t on 1 plus t squared. And then you would just cross out the you could cross out the
Hold on.
2t. Yeah.
What are you going to do with this fraction that you're left with 2 on 1 plus t squared?
You would flip it over to get
Yeah, you
1
will
plus
flip
t
it.
squared.
That's better.
And then you would cancel out the you just and it equals t.
Okay, thank you. Let's just get everyone having a look at that, seeing if they agree with it. And I think it's a good time to make the point that you can see we're not really doing much trig, if any. We're just doing simple algebra, or simple if you're good at your algebra by now. Any questions? Not yet. Does this make sense to you? Everything
Yeah.
we
I remember it from last year.
okay? You did T formula last year?
Yeah,
Oh,
you
with me.
taught. Yeah.
Oh yeah, I forgot that. I forgot that we've actually finished off most of everything. Okay. Good point.
Don't worry about it. So let's go it again.
Yeah. No, well, at least it's good. Second time round, it's making a lot more sense, which is good. Good to hear. All right, B. Let's do. I'll write it up first. 1 plus tan theta on 2 must equal to sec theta. Okay. Left-hand side. Left-hand side. So 1 plus tan theta. Tan theta just go up. Look at your triangle. Opposite over adjacent. Tan theta is 2t on 1 minus t squared. 2t on 1 minus t squared times tan theta on 2. What does tan theta on 2 equal to?
T.
So, yeah, tan theta on 2 is just t. Easy. 1 plus 2t squared on 1 minus t squared. Next line. Common denominator. 1 minus t squared plus 2t squared. Minus t plus 2. Boring stuff, you guys. Look, easy. And you know that is 1 over cos. And if you didn't know that was 1 over cos, it's okay. You can cheat, right? You know it says sec theta. So you know sec theta is 1 over cos. You know cos is 1 minus t squared, and then you just fudge it out. If you couldn't do that from here to here, then you would stop at this line. So you would stop. Then you would say right-hand side equals sec theta. Sec theta is 1 on cos theta. Cos theta is 1 on 1 minus t squared on 1 plus t squared, which equals to, flip the reciprocal, that equals to the same as your left-hand side. So it's up to you and your math. If you couldn't exactly do the next few steps like this that I've done, then just stop, go to your right-hand side, get to an answer, and then say, therefore, left-hand side equals right-hand side. Okay. Any questions for that one? No? All right. I'm pretty happy with that. I think even the next one, there's nothing to do. So 3 sine theta, I'll just show you the answer. 3 sine theta plus 4 cos theta plus 5. Just make it, where is it? There it is. 3 sine theta, 3 times 2t on 1 plus t squared plus 4 times 1 minus t squared on common denominator. There it is. The top, simplify it. There it is. And you want it to become t plus 3 squared. Well, just factorize it as a perfect square. You're done. Easy, 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 easy. I promise you guys, easy. All right, Thursday. Okay. Let's look at something that is actually going to be a little bit hard, which is 3D trig. So this will probably be where you might not like trig. Whereas the rest of what we've done, the rest of extension 1 trig, is just formulas based. So once you know your formulas, you just need to sub them in and do some algebra. This, you actually have to understand how to draw these out and how these work and everything like that. Okay, let's read it first. So the angle of elevation of a tower CD of height h meters from a point A due east of it is 28 degrees, and at a point B due south of it, the angle of elevation is 36 degrees. A and B are 400 meters apart and on the same level as the base D of the tower. Show that AD is equal to this and hence find the height. So confusing, right? Can everybody confirm that this is really confusing?
I can't understand that, sir.
Yeah.
Yeah, good. Good. So I think at least now you know your weak point in trig. You also know what section you really want to focus on when you learn this at school. So most of the other stuff, like you'll get your head wrapped around it, you'll go over these videos and it shouldn't be too hard. Once you know your formulas and you memorize your formulas flawlessly, really it's just basic algebra. This, unfortunately, I can't say the same to. This actually requires a bit of time. So let's see if I can make it easy for you guys. I'll make it as easy as I can. The first trick I can tell you is how to actually draw your 3D triangles. The best way is to first draw a straight line. So that's going to be your vertical tower or cliff or whatever the question's going to be saying. Then you're going to have another one that's going to be, unless there is a different bearing, which we'll do bearings very soon. It's just going to be to your right. And then you're going to have another one that's going to be what? Southwest. So let's say there. Cool. And that's going to be our 3D trig diagrams that you're going to draw. And watch. Once I connect it all, hopefully we can see a 3D triangle. Can we somehow see a 3D triangle from that?
Yeah.
Beautiful. So now let's see if we can read the question again and actually put everything in and see if it actually makes a bit more sense. The angle of elevation of a tower CD, of height h meters, h, from a point A due east of it. So due east, A, and the angle of elevation is 28 degrees, 28. And at a point B due south of it. This is south, because the way you got to look at this is a 3D shape, right? This pole is sticking out of the ground. So if the pole's sticking out of the ground, this would be east, and this would be perpendicular to the pole, which would still be south. So just keep that in mind, which means that's a right angle. East and south, that's a right angle. Are we all good at that point?
Will it always be south and east?
Say that again.
Will it always be south and east?
No. We're going to, like, the next question or so will be a different bearing, but you're still going to draw it this way. Because I mean, look how easy it is for me to say there was a bearing here of, let's just say, 120 degrees. What are you going to draw here? 120 degrees now. Right? I mean, the next few is going to be easy. It's just you understanding that this was east, and if this is south, then this is going to be a right angle now. So the triangle that's formed at the bottom of the floor, this bit here, is actually a right angle triangle. The angle of elevation is 36 degrees. So there's 36 and there is B. A and B are 400 meters apart. There's 400. And are on the same level as the base D. They have to be, base D. Yeah, fine. Base D, make that into a C. They have to be on the same level because they're all on ground, right? That's on ground, that's on the ground, that's on the ground. This is sticking out of the ground. And then that's at you looking at the top of the tower. That's another person looking at the top of the tower. Okay, I'm going to stop there. Maybe reread the question, look at the diagram again, see if you're able to understand how I drew that. Ask me any questions you've got right now. Any questions, you guys? Nothing? Everything made sense there? All right. That's the first trick. So the first trick was how to draw the diagrams. And then these are elevations compared to bearings. Bearings will be down here, okay? Which we're going to do soon. So elevations are going to be these ones. Bearings are going to be on the ground. What else do you need to know? Okay. The next thing, the next bit of 3D trig is that eventually, so ignore A for a second, but eventually you want to find the height of the tower. So we want to find H. Now, the traditional way that you've done trig and finding sides, so let's just say this question, to find D, you're actually going to use methods to find D, right? So you'll probably do opposite over hypotenuse. To find V, you'll do opposite over hypotenuse. To find H, you'll do adjacent and hypotenuse. Let's say if it was a sine rule question, you would have done, let's just say X on sine this and 15 on sine that, and you would have found X. Let's say if you wanted to find theta, you would have actually done, you know, cos theta is equal to, and then blah, 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 or sine theta over this is equal to, okay. What I'm trying to get you guys understanding is before, traditionally, when I was asking you to find X and theta, you actually were finding X and theta. With 3D trig, it doesn't exactly work like that. What's going to happen is you're going to have an equation somewhere here, let's say, for this length. You're going to have another expression or equation for this length, and then you're going to do Pythagoras' theorem or cosine rule, depending if it's a right angle or non-right angle, to solve for H. So you actually use this triangle down here to find this height up here. Is that clear? You'll use this triangle here to find this H, which is super strange, but it's just the way it's got to be. Is that, anyone have any questions there? Do you understand what I was trying to say with the other questions that I was saying? Like, usually when you're trying to find height, you actually find the height. Whereas in this case, when it says find the height, you do not go ahead and find height. It will just work out. All right, let's have a look at a question. Hopefully it all makes sense right now. A, show that AD is equal to H on tan 28. Show that AD is equal to H on tan 28. It's always going to be tan or cot, I'll tell you now. But here we go. Opposite over hypotenuse. So I know that AD is equal, sorry. I know that tan 28 is equal to opposite over hypotenuse, which means AD equals to H on tan 28. Cool. Find a similar expression for BD. Well, again, tan 36 equals opposite over hypotenuse. So BD equals H.
Opposite over adjacent.
Opposite over adjacent, yeah. You get BD, that's it. That's your A, done. Now, just so you guys are understanding what I'm trying to say with these three to find h, some questions they don't give you a. They just say find the height. You need to know the way you've got to do it is to find this length and then this length and then use either Pythagoras or cosine to actually find this height. So you have to always do A for yourself, even if they didn't give you A. All right, B, the question just says, hence, find the height of the tower. Well, it's actually easy now. I know that AD squared plus BD squared must equal to 400 squared. AD is H squared on tan 28 squared plus BD is H squared on factorize your H squared out. Bring this guy all over. Obviously, I'm not going to write it again. I'm just going to label it as A. Divide by A. And then square root your answer. All right, I want to try to put it in my calculator. I would recommend you guys try to put this all in your calculator and see if you can actually work out the height H, and then we'll go through the question again. Okay, 1 on 10, 28 squared plus 1 on 10, 36 squared.
So I don't put a 10 squared into the calculator.
Okay, then good question. Let me do it with you. All right, you ready?
Yeah.
Press the fraction button.
Yep.
1
Yep.
over, go down, press 10, 28, close your bracket,
All right.
and then I do want to check something. Just give me 1 second. I just want to check if your calculators are going to do it right if I do that and that. Yeah, good. So 1 over 10, 28, close bracket, and just press squared.
Okay.
Your calculator knows, but you have to close your bracket. Otherwise, if you don't close your bracket, you're doing 28 squared.
All right. Yeah, makes sense.
And then do it again. Plus fraction 1 over 10, 36, close bracket, squared. Press equals. I think I got an answer of 5.4 for this bit. And then you just do 400 squared divided by that answer, and then you square root it. And hopefully, if you guys can get this out, that would be amazing. 171.63. Please confirm once you're able to actually have that answer, because
Yeah.
putting it in our calculator. Yeah, put it out. Good. Thank you.
Yeah.
Nice. Great. All right. Let's go back up. Please tell me which line you want me to go through again. I think A made sense. Part A, I think that was fine. And like I said, please, if they don't give you part A, you have to know to do part A. So just keep that in mind. That is the logic. And you can see we found H without actually finding H, right? The traditional way. Do we understand what I mean by that, or what I meant by that now? We didn't actually solve for H. We just used Pythagoras, and somehow, using a bit of math, it just worked out to solve for H.
So our teacher told us to change 1 on 10 squared into cot.
But why would you? Because you can't use cot in your calculator.
Yeah, I don't know.
Yeah, I
He's
don't
getting
know.
sacked. He's getting sacked.
He said
So-
to make it into a simultaneous equation.
Sorry?
the two triangles into a simultaneous equation.
No. Overkill. Don't do that.
Yeah, it's like 2 pages of writing.
No. That's it. Easy. Does this make sense to you so far?
Yeah.
Yeah, look, you could have written this in case the question did say HCOT, you could have written it as HCOT 28, of course, but you can't do anything with COT on your calculator. So that's why I usually don't like writing COT. I would write it as 1 on 10, but I mean, yeah, you can write COT, it's just you can't do anything. When you're here, you're not going to be able to do anything with COT squared 28 and COT squared 36. You still have to change it to 1 on 10.
Yeah.
And that goes for all of the others as well, like sec and cosec, even if they were there, you can't use them. So you can write them, you just can't put them in your calculator. Okay. All right, let's look at another one. Simultaneous equation. No, I've never seen that one. No, wait, all right. Your teacher, interesting character. Would like to meet him.
Interesting bloke.
Interesting book. All right, let's have a look at this one. There we go. Copy to clipboard. Bang. Let's see. We'll follow my trick for the diagram, I guess. And what else do we need to know? And that I said you usually are not finding H. You're gonna probably need the bottom triangle and so on. And there's a difference between bearing and elevation. All right, let's see. Without reading yet, well, let's read it. Why not? The angle of elevation of a tower CD of height H from a point A due east of it is 40 degrees. Again, this one's due east. Is 40 degrees. So the elevation is 40 degrees, and that's point A. From a point B, the bearing of the tower is 42 degrees, and the angle of elevation is 35 degrees. So that's B. Oops. There we go. And that's 35 degrees. Andy, for example, does that make sense so far? Elevation 35 and elevation here 40. Good. Oh. A and B are 200 meters apart and are on the same level as the base D. So again, that's D and that's C. We haven't put in our bearing yet. Now, just so you can understand this, from a point B, the bearing of the tower is 42 degrees. So the way that works is if you've got little compass bearings there you go, and you've got little compass bearings on the ground here as well. From B, this is 42 degrees. Right? Can we see that? To get to this, wait, let me use a different color. When you're doing bearings, you've got to draw these. That's these compass bearings. Let's just draw it. Bang. Bang. Okay. What's the angle from here to here? From here to here on the ground, not elevated up. It's got nothing to do with 35 degrees. Anyone know that the angle from here to here?
42.
From a point B, the bearing of the tower is 42 degrees. So that bearing from here to this, to the tower, is 42 degrees. So that means if I draw my compass bearings here as well, alternate angles, what does that mean about this angle here?
8.
It's also 42 degrees. So what does that mean about the whole thing?
220. Oh,
That's okay, Andy. Does it? Do you get?
yeah,
Do you get
that's
what's
a
happening?
90-degree angle, and then
That's a
plus the
90-degree
42.
angle. Yeah, plus 42 degrees. And then, so for A, it says show that angle BDA is 132. Well, I mean, if you're going to draw your diagrams, which is what I'm recommending, you're going to just be able to go from diagram equals 132 degrees. So we can tell you got 90, we can tell you did your bearings, 42, 90, this whole thing becomes 132. Did anybody not understand this bearing bit? Because I do hear sometimes students say, oh, how'd you know that wasn't 35 degrees? You've got to remember this is on the ground, BD's on the ground, you've got to imagine that, and then this 35 degrees is lifted up to the top of the tower, or the top of the flag, or top of the pole, whatever it is. So that is 35 degrees. This is on the ground, 42 degrees. So imagine north and then 42 degrees to the right. Okay. I'm going to continue then, if there's no questions. B. Show that BD is equal to H tan 55. Okay. BD, it says 55, so there's no point of choosing 35. You might as well go ahead and choose 55, which is up here. So that would be opposite over adjacent. Tan 55 is equal to opposite over adjacent. Therefore BD equals H tan 55. Find a similar expression for AD. AD, it's up to you. You wanted to use, I don't know, 50 degrees, or you want to use 40 degrees. Doesn't really matter. I'm going to do 40 just to show you that it doesn't matter. Tan 40 is equal to opposite over hypotenuse. Sorry, over adjacent. And then AD is equal to H on tan 40. Any questions? Okay, C. Find the height. Well, I think you guys know what I've got to use. Can someone tell me what I'm going to use now? It is definitely this triangle, which is what I said before, but it's not Pythagoras.
Is it the AD equals
Cosine?
H on tan 40?
AD equals H on tan 40, yeah. But, yeah, for this triangle, you're going to use cosine rule. That's the idea. So you're going to go with 200 squared, C squared, equals one side squared, plus the other side squared, all right, I might run out of space, so I'm going to just start it up a little bit on the left. See. All right, 200 squared equals a squared. So what did I say? H squared on tan 40 squared plus the other one, which is H squared tan squared 55 minus 2 times a. Still ran out. Times H on tan 40 times cos C, which is 132 degrees. Hopefully you guys are writing just that a little bit neater than I am. What I do, and it's always the same method, same way, every single question. All you do, you can see there's H squares. This is H times H, which is also H squared. So you're just going to factorize it out. And then you're just going to get this big monster, and you're going to divide it. Is anyone confused? So H squared equals 200 squared on A. We're going to label that as A. And then don't forget, we're going to square root it for H. Go and see if you can actually put that in your calculator without making a mistake. All right, my turn. 1, 5, 10.
Sam, I got 87.92.
Okay. Yep, 87. We'll just wait and see some others.
I got 83.5.
Okay.
So I got 83.5 as well.
All right. Let's have a look at this 87.92 then. Stefan, I'm guessing. Well. Okay. Do you still have it on your calculator screen? Do you still have it on your
Yeah,
calculator?
I've still got it.
All right. Go. Just share your webcam if you don't mind, and show me what you've written off.
200 squared over. Wow, I need to go all the way to the left now.
Okay. Can you just share it to me on your on your video cam, like on Skype?
Oh yeah.
All right. Wait. Wait.
I don't know if you can see that.
It's super blurry. I see nothing. Nah, that failed. Nah, it's not gonna work.
Wow, let me try to flip this. How do you flip camera on this?
It's not about the flipping. It's blurry.
Oh, bruv.
Yeah. No, I can't see nothing. Seriously, there's no point. It's not you. It's probably the like. It's just the digits and stuff won't work. It won't work. Don't worry. We tried.
There are 3 buttons on the bottom of your screen
Nah.
that you can click. You've got the option of unblurring your background.
What?
You reckon it's because of that?
Maybe.
Nah, just leave it. Don't worry about it. All good. All good. Leave it. It's fine.
Wait, what's the
just
answer?
Tell me what you said. 83.5. Tell me what you said. 200 square.
200 squared over.
Yeah.
1 on 10 40 squared
Yes.
plus 10 55 squared
Yeah.
minus 2 10 55
Times
1 on 10 40
times cos.
times cos 132.
Maybe. Look, it could be just you would have put something in wrong. I think. Did anyone else get 87.92? No.
Does
Well,
that
yeah.
come up to 7730?
Well, let's say this bit here, right? Let's put the
Yeah.
let's put that bit in. All right, hold on. Let me do it now for you. 1 on 10 40 squared plus 10 55 minus 2 times tan 55 times 1 on tan 40, close bracket, times cos 132, close bracket. I got 5.737. So go and just put this bit in. Just put A in one more time on your calculator. Did you get it out? 83.5?
Yeah.
Okay.
1 on 10.
40
40
squared.
squared.
Close your bracket, right?
Yeah. Plus 1055 squared.
Oh, no, not 5.3, sorry. I didn't. Wait, did I square it? Yeah, I did square it. Yeah, keep going. All good.
21055. Yeah, 5.7 I got.
Yeah, and then now just do 200 squared divided by answer and then square root it. So something went wrong somewhere. I don't know. The first time.
Yeah, now I got 83.49. So,
Yeah.
0.5.
Yeah. All right. Let's try another one. Maybe I'll let you guys just read it, maybe draw your version of it, and then we'll do it. Just have a quick read, maybe draw what you think you know now from just those two questions, and then we'll start. Okay, let's do this. The angle of elevation of a tower QR. Of height 80 meters. Okay, so the height is this time 80 meters. At a point y due east of it is 45 degrees. Y 45 degrees. From another point x, the bearing of the tower is 30 degrees. I think we kind of understand what's happening there. So we know the bearing is 30 degrees, so therefore we know this bit here is also 30. Right, which means this whole angle, which is the more important one, is 120 degrees. And then the angle of elevation is 28. Bearing, yep, and that's x. The points x, y, and r are on the same level ground. Cool. Show that angle XRY is 120. I think we know that by now. 90 degrees plus 30 degrees gives us 120. So bearings done. B, show that XR is equal to this. Okay. So again, for B, I do tan opposite over adjacent. So tan 28 equals opposite over adjacent. And then XR equals 80 on tan. 28. And RY is 80. RY, again, tan 45 equals opposite over adjacent. RY is equal to 80 on tan 45, which is just 1, so just 80. Any questions there? No, no questions. All right, this time obviously I gave you H. As you can see, you don't need to find H. You actually need to find XY, which we'll label it as X. What are we going to do? What are we going to use again to find X? Cosine rule again, right? So we've got a triangle there, we've got X, we're going to use our cosine because we've already got RY and we have XR. So here we go. X squared equals XR squared, so 80 squared on tan 28 squared plus 80 squared minus 2 times 80 times 80 on tan 28 times cos 120. And then plug it all in, square root answer. Stefan, does that all make sense?
Yeah.
All good. This time our answer should be 202.7. Someone please confirm that they also got that.
Yeah, I got that.
Nice.
Yeah.
Cool. All right. Working good. How are we finding this 3D trig? Does it make a whole lot of sense the way I'm doing it?
So much better than school way.
Yeah.
So much better.
Just I mean, if you just follow the steps now, they really should be. They should be fine. Look, I'll actually get an exam question out. We'll go and look at a 3D trig trial HSE question or something, and see if we're able to answer that. Then I think we can safely say we've mastered this. But it's pretty much the same concept each time, over and over again. So I'll do that. Anyone still copying anything down? No? All right. Let's have a look at some exam questions and see if we can apply everything we've just done into exam questions. So year 11 extension 1 exams, 3 units, trig and polynomials. No, nothing in there. 3 zeros, April. Yeah. Lakers assessment trig. Section 1. No 3D. Oh, there. All right. Since this is a trig exam, might as well start from the beginning. Do each one until we get to these 3D trig questions, which looks like it's more there. Where is it? Right there. 2 ships. Beginning is just advanced stuff, so why not? Let's do this. Do you guys want me to send this to you right now, or was you going to work on it from here and then I'll just send it across? Does anyone actually want a copy of it right now? I don't know, for those who've got a pen and want to write on it. No. All right, let's go. Start with the first one. Find the exact value of tan 120. Plug it into your calculator. See what you get. Just in case you guys mix it up, you are allowed to sign a negative. You're not allowed to inverse sign a negative. All right? So you're allowed to put this into your calculator. Anyone have an answer yet for this one?
Is it root 3 and 2 by any chance?
So the first one is negative root 3 times, this one's I think negative half. So the answer becomes?
Root 3 and 2.
Root 3 and 2.
Yeah, thank you.
Can someone confirm that that's true?
Yeah.
Nice. Next one. Do the next one. 2 cos 45. Tan 60. Actually, you know what? We'll just do one by one. Hold on. It's better that way. Just so everybody can contribute. All right, Andy, you're gonna start us off. So
Okay.
you're gonna start us off. Let's go. Cos 45.
1 on root 2.
1 on root 2, and then tan 60.
Tan 60. That is root 3.
Root 3. So the answer is 2 root 3 on root 2, and then what are you going to do? Multiply both top and bottom by?
Wait, what?
You're allowed to have surds in the...
Oh yeah, root 2 times by root 2.
If you don't write it in simplest form, you don't get full marks. Cool. Next. Aya, next one.
Will I just put that in as tan first?
Tan, yes, So tan 45 becomes 1. 1 squared is just 1. Plus cosec. Cosec is 1 on.
Fine. So that would just turn into 1 as well.
Yep. And then what's sine 90? 1. So what's your final answer for this question?
Yeah.
Thank you. Next. Azra. Sine theta, cot theta.
Would equal to sine theta times cos theta on sine theta.
And then?
Which is sine theta cos theta on sine theta.
Yes. Then you would just
And
cancel the
cancel.
sine.
Gives you cos theta.
Good. Thank you. 1 on cos. Simplify this. 1 on sine squared 35 minus cos squared 35 on sine squared. Ah, interesting, annoying question. All right. Who's next? Ben.
Hello.
Okay, you probably saw what I was doing anyways because I was.
No, I didn't do that.
All right, fair enough. Cosec squared 35.
Oh, I do it now?
Cosec squared, what is it going to be?
Oh, it's just 1 on sine. Squared 35 minus cos. Yeah, cos squared 35 double sine squared 35.
And then?
And then, since they're both common denominator, you can just minus it.
Yep, and then the top becomes?
Sine squared 35, and it's just 1.
Because 1 minus cos squared theta is sine squared theta, where theta here is 35 degrees. They were just being a bit annoying with the angle, right? And then sine squared on sine squared is equal to 1. Anybody not understand that one? That makes sense? Okay. Next, Greg. Simplify this.
3 sine squared a plus cos squared a. So basically what you do is you know that sine squared a plus cos squared a equals to 1, but you can't do that here. So
But you can use
Yeah.
one of them. So
Yeah.
maybe just change sine squared to
2 cos squared, yeah. So you
we're
can get
gonna
3 cos squared minus 1, or 1 minus cos squared, sorry.
There's no point of changing cos squared to sine squared because you're just going to return to the same expression. So you'll leave it. And then
You end up with cos squared a.
3 times 1 is 3. 3 take away 3 is gone. Minus 3 cos squared plus 4 cos squared. And as you said, you end up with just cos squared a. Good job. If you had changed cos squared, your answer would have been 1 minus sine squared, which you would have had to simplify again to cos squared. So it wouldn't have made a difference. Your answer at the end of the day has to become cos squared. Good. Mayet. Next one. IV. You feel like so far you have full marks?
Me?
Yeah, if this was your exam, would you be at full marks so far?
For question 1, yes. Question 2, I not really don't think so.
Okay, what bit? The first one, second one, third one? All of them?
I think it's like the remembering which one I should switch them to.
Yeah, fair enough. All right, let's go. What are you going to do with this one then?
Would you change cos squared to sine?
Yeah, that's not an issue just yet. Just look at it one more time. You should see, something should be screaming out at you. The fact that there's 2 of these guys. What are you going to do first?
They cancel.
No, you can't. How can you cancel it?
Um,
You would factorize it out.
okay.
Factorize it, and then what are you left with?
1 minus squared theta.
Then what's 1 minus cos squared theta equal to?
Is it the
1 minus cos squared is equal to sine squared. Right?
yeah?
And that becomes sine to the power of 4 theta. Squared and squared. Okay. Next one. Who's next? Rosemary. Rosemary, you ready?
Yeah.
Let's do this. LHS. Okay, it's going to be a little bit tricky. Unfortunately, you got the tricky ones. So LHS. 1 minus tan squared theta on 1 plus tan squared theta. We want it to become cos squared minus sine squared. Fingers crossed. Here we go. 1 minus. What are you going to change tan for? Or 2? You're going to change tan to. Tan theta equals what? Do you remember it?
Sine on cos.
Yeah. So this one's going to become sine squared on cos squared over 1 plus
1 plus sine squared on cos squared.
and then next line common denominator, so this becomes cos squared minus sine squared
Yeah.
on cos squared over cos squared plus sine squared. And what does cos squared plus sine squared become?
1.
1. What are you allowed to do with these cos squares if they're both in the denominator? Do you know or you don't know yet?
Cross them.
Yeah, you're allowed to
They
cross
cancel
them.
out.
And then you're left with, obviously,
Cos squared theta minus sine squared theta.
which equals to right hand side. Thank you. Next one. Stefan, you're going to do the next one.
Yeah.
Do you feel like you could have got full marks yet or not really?
Why you talk to me?
Yeah.
Oh yeah.
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 Confident. All right. We're
Wow.
trying to get back to the sec
What's the
theta.
question? Let me just write down the question.
Yeah.
Was theta
On 1 minus sine minus tan, and then we want the right hand side to become sec theta.
So this one you got to do the left and right hand side, don't you?
Maybe. Let's start with LHS first.
Alright.
So, are you going to change
LHS.
anything to this bit?
Let's change cos.
To what?
Yeah.
To what?
1 minus t squared over 1 plus t squared.
Oh, okay. Hold on. Good point. Let's just see, so you can understand that. It's not even here. No, look, with that one, they have to specifically tell you t equals tan theta on 2. So that you know to do
Okay.
formula. Yeah, so no. Can you change cos theta or sine theta for anything? No.
No.
Minus, what
But
are you going to
change 10.
That's it. Becomes what?
Sine theta on cos theta.
And then what's your common denominator now?
Cos.
Then cross multiply.
Cos squared minus sine
You got
squared
it.
theta.
Minus sine theta times 1 is sine.
Oh, is that a
Negative-
1?
Yeah, it's a 1.
Oh, I thought that was a bracket.
And negative sine times positive, negative sine becomes positive.
Sine squared.
And then what's cos squared plus sine squared?
Is 1. So it becomes 1 minus sine theta. And you can cross that out to become 1 minus cos, 1 over cos theta,
Which equals?
which equals sec theta.
What we wanted. All right. Novi and Emma set out on a walk. Novi walks on a bearing of 244 degrees. So this is not a 3D trick, this is just normal 2D. Novi walks on a bearing of 244, which would be something like that. At a speed of 3 kilometers per hour. Emma walks on a bearing of 105. At a speed of 2 kilometers per hour. Draw a diagram to represent calculate distance between the two girls after 3 hours. Okay, well, after 3 hours, what's the distance that you've traveled here? After 3 hours at 3 kilometers per hour, you would have traveled 9 kilometers. At 2 kilometers an hour, you would have traveled 6 kilometers. You're trying to find x. You need this angle. 244, take away 105, 139. Can anyone tell me what I'm going to use to find x?
Cosine.
Cosine. X squared equals 9 squared plus 6 squared minus 2 times 9 times 6 times cos 139, and then you're just going to square root the answer. To the nearest meter. You don't write it to the nearest meter, you lose 1 mark. Easy. I hope it shows you move away from your textbook questions. You just got to know one of everything. One of this, one of this, one this, one. Once you know a little bit of everything, you've got to start doing exam questions. It's the only thing that's going to get you your highest marks. B, it's fairly straightforward. Just use the cosine rule, find the nearest degree, find the area. We haven't done that. We'll be doing the easy stuff next week. So you don't have to worry about that right now. Now we'll look at this 3D triangle, which this person couldn't do as well back in 2006. So let's see if we can help him out. Two ships, P and Q, are 1,400 meters apart. L is the top of a nearby lighthouse. The angles LPQ is the top of a nearby lighthouse. The angles LPQ and LQP are 61, 50 respectively. The angled elevation of L from P is find the height of the lighthouse. Well, that's just annoying. Two ships are P and Q are 1,400 meters apart. LPQ. LPQ. Yeah, that won't work very nicely for you guys, so I wouldn't want to do it this way. LQP. If the angle of elevation of L from P is 6 degrees. Two ships are P and Q, 1,400 meters apart. This might not be a 3D trig actually. Hold on, okay. So that's your height of your lighthouse. The two ships P and Q are 1,400 meters apart. So I'm going to assume Q is there. This would be 1,400 meters. The L is the top of the lighthouse. Yep, the angle's LPQ. LPQ. No, I'm doing something wrong. What am I doing wrong? This is a 3D trig. LPQ. Yeah, it's really easier for you guys to see it that way, but it doesn't matter. I've got to do it the way I've done it with you guys now. All right, here we go. Two ships P and Q are 1,400 meters apart. L is the top of a lighthouse. It is a 3D. It has to be 3D because I've got this vertical side here for the lighthouse. The angle's LPQ, LPQ. So this angle in here of this triangle, I'll just highlight it so it's a bit easy to see. That triangle is 61 degrees. LQP is 52 degrees. And it just says the elevation, so elevation to there is 6 degrees. Find the height of the lighthouse. Okay. To be able to do that, I need, if the angle of elevation of L from P, angle from P, the angle of elevation of L, oh yeah, it is right. What am I doing? From P is 6 degrees. Find the height of the lighthouse. So what do I need to find? I need to find, why has this one got me? 52 degrees. People I'm drawing it. I feel like I would have drawn like this. Would have made a difference. 6 degrees. That's 1,400. No, it's fine. Let's do it. All right, let's go. So opposite over, I'll need to find this one here. Opposite over hypotenuse. What's that going to be? That's going to be sine. Sine 6 degrees is equal to opposite, which is h, over hypotenuse, which would be LP. So LP equals to h on sine 6 degrees. Okay, so this bit here is equal to h on sine 6. And then, can we see the yellow triangle that I've drawn? So I'll just draw it again somewhere here. I've got 1400 here. I've got h on sine 6 there. I've got this angle being 61 degrees. I've got this angle being 52 degrees. I need that angle, then I can just do my sine rule. These two and these two. So unfortunately, this is just a slightly different case than the ones that we've been doing. But that's the beauty of exam questions. You probably won't come across a question like this in your books. So 67. And then, fairly straightforward, you're just going to go 1400 on sine 67 must equal to h on sine 6 all over sine 52. And then times by sine 6. And you should get h. Talk to me, you guys. Did that all make sense? No?
Sort of. Yeah.
Sort of.
Can you read that again, please?
Yeah. So two ships, P and Q, are 1400 meters apart. So these guys are now going to be 1400 meters apart. I'm not sure if this is a right angle, like you were saying last time, Andy. Oh, crap. Actually, that's not a right angle. If that's not a right angle, I've already done this wrong. The angle of elevation of L from P. Oh, what am I saying? This must be a right angle. Why must that be a right angle? Can anyone tell me why that must be a right angle?
The lighthouse.
The lighthouse to a ground must be what?
90.
Yeah, a lighthouse, like anything that's sticking
Could
out
be leading
straight.
power of diesel.
Except that. Anything that's leaning out, that's coming out, that is straight, vertical, obviously, to the ground, must be a right angle.
But Sam, is that like really valid though? Like, can't
Yeah.
like a building be angled at any angle realistically?
Realistically, but the idea with all of these questions, they're all going to be perpendicular. Otherwise, they'll just make things a lot more complex. Not because of this angle here, they'll just make things more complex because this H would be, yeah, it'll just make things a lot, way more complex. I mean, I'm sure I can check the answer and see if I've done it right. But I'm confident anything that's vertical to the ground will always be right angle. But if you're questioning my math, I'm more than happy
But
to.
does it say like it's vertical to the ground though in the question?
It does not. But the assumption is if it's a lighthouse, the lighthouse would have been vertical to the ground.
Yeah. Fair enough.
1, 2, 5. That's so funny. They couldn't even get it out. Okay. The answer is question mark because it is a little bit different. You got to think really outside of the. That's funny. Really outside of the norm here because it's not your typical question for 3D trig. So usually I did say the bottom is the triangle we're going to deal with. The problem is if they're going to give me the angles being LPQ and LQP, these angles 61 and 52, the triangle I've got to use is this outside one. So maybe that's, yeah, it got me for a second there as well. But anyways, so I can hand on heart, that's 90 degrees. I can guarantee that. So don't worry about that bit. Back to it. Sine 6 degrees equals H on LP on LP. Then we worked out what this length here is. Once I know what length that is, I don't actually need this length And the reason why I don't need that length is because to do sine rule, I need just 2 sides and 2 angles. And the 2 angles I chose must be opposite the sides I'm going to use. So that's 52 degrees. So I chose H on sine 6 degrees with 52. And then I need to work out this third angle sum of a triangle, and did that with 1400. And then just times by sine, you'll get H. Andy, what do you want me to talk about again? Tell me.
The H, like I times the sine over the sine 52 to the 1400.
Yeah.
And then I timed the sine 6 to it, and I got a negative
You got a
0.15.
negative. How? When you this?
Yeah.
So you're at 1400 on sine 67.
Yeah, so I did sine 6 and then timesing 1400 sine 52 on sine 67.
Yeah. What
And
did it
now
say?
I've got negative 0.15.
I'm confused. How? Sine. Sorry. Say it again. What you've got?
So sine 6, yeah,
But
right?
why are you writing sine 6? Why aren't you writing 14? So, but are you putting sine 6 into your calculator first? Is that what you're saying?
Yeah.
Right. I think what you might. Did you close your bracket?
No.
Yeah.
Okay. Yeah, I see. I've got 125 now.
Yeah, it's 1400 times sine 52 degrees times sine 6 degrees on sine 67. And you should get 125.
Alright. Yeah. All goods now.
Okay. Anybody else? Ayat, does this make sense? Marietta, does this make sense? What we've done? And obviously, it is a lot, it is different to the one we did. I hope the diagram you would have chosen is exactly the same that I've been showing you. It's just unfortunately, the angles are going to be a little bit different because of this.
How do you know when to do that?
Sorry, say that again.
How do you know when you got to do this way?
What do you mean by this way? As in this specific, the fact that it says LP, I didn't. I mean, that's why you probably saw me for a minute or two. I was struggling to get the shape of it out or what it's trying to say. The only thing I told myself was, no, Sam, don't change. You got to keep everything the same. Don't try to do that. So I was like, all right, let's go back. And then once I realized LPQ is 61 and LQP is 52, I realized the triangle I'm meant to deal with is the outside one, because the inside one, I don't have what the bearing is. I don't know if that's south. I don't know anything else about this bit.
Yeah.
So I can't actually use the bottom anymore.
Mm.
And that's how I realized I got to use the top one. But look, all I can tell you is exams, right? Like as you keep doing more and more exam questions, you'll realize these ones are different. All right, what do we have left? We've got these 3. We won't have time to do more, if any, really. Look, I'm going to save these. I would like you guys, actually I'll just save it. I would like you guys to do question 3 for homework. And in fact, during the week, if you don't mind, maybe tomorrow, maybe later tonight, if you want to just stay back and do it, take a photo of your answers and just send them straight to me. Desktop. Save. So I'm going to send that into your Skype. Your homework really is just to do question 3, A, all the way to G. I mean, there's some work just solutions here if it helps, but I would like to see you working out for A to G and just send it to me individually before next week, please. Thursday, save that, you guys don't need that one, you already have that